Hey, this is Joel Duff. Welcome back to the channel. A few days ago, I recorded this video, River Meanders Don't Happen in a Megaflood. It was a critique of young Earth flood geology, showing that there are river meanders deep inside the sediments of the geological column. And the question was like, how could there be streams and rivers that are meandering, right? And creating these flow patterns that we see on the surface of the earth today in the middle of a giant chaotic worldwide flood that's laying down thousands of feet of sediment over just days, hours, and maybe weeks, possibly a month. And I said, flood geology, it just don't work. It does not explain the things we see with our eyes, the observations we make from the geological column. I wanted to follow up on that, partly because I had a geologist write me and sent me a paper, which is fantastic and has much better images than the ones that I used in that particular presentation. And so I just wanted to like go a little bit farther and show a couple more examples of evidence of meanders, or in this case, it's going to be incised valleys, cuts of rivers in the geological column. And before going on, and before showing you that paper, I'll just remind you that I recorded another video about a year ago, Entrenched river bends, in which we just looked at some surface features of incised valleys that are meanders, essentially, that have been trapped by uplifting land that's uplifting very, very slowly. And so the river is eroding down, preserving the meandering. This is the San Juan, this is the Goosenecks of the San Juan in southern Utah. Here I am standing there looking at, this is absolutely one of my favorite places to go. I've been there several times. And I took this picture here a few years back. And so you see this incredible topography and you see this river that has incised straight down. This is not what you would expect from a massive flood or large, water coming off of a continent after the flood at very fast pace. You're not going to get these meandering, incised rivers at all. Here's another large bend in the San Juan River. So with these incised river valleys in mind, let's go take a look at this paper that I was sent. This paper is really awesome. And it's just what I said in my last video, that you just read the literature and you just are just hit smack in the face with like, how in the world would a global flood explain this data? It just doesn't. It just doesn't. I don't know what Andrew Snelling and others are thinking if they actually read any papers like this. How are they not just, how does their mind not explode when they try to think about how they can explain this in a young Earth context? All right, so what do we have here? From the Journal of Sedimentary Research in 2010, we have From Bars to Valleys, the sedimentology and seismic geomorphology of fluvial to estuarine incised valley fills of the Grand Rapids Formation of the Lower Cretaceous, Iron River Field, Alberta, Canada. Sounds like a thriller, doesn't it? Doesn't it just make you want to like, let's read this whole thing word for word? No, we're not going to do that. We're just going to look at some pretty pictures. And I'm just going to tell you a little bit about why what you're seeing is important. First of all, let's note the date. Right, they're looking at Cretaceous rock. So we're looking at from the Albian period, it's a little over 100 million years old. So from a young Earth creationist perspective, this would be rock that was laid down clearly during this flood year, just 4,350 years ago. And so all the material that I'm going to show you would have had to have been laid down extremely rapidly all at one time. Keep that in mind as we look at what we're going to see here. What do they have? What have they found? Oh, let's see. The authors here, Maynard, Feldman, and Alway, they're all employees of ExxonMobil. There's a whole lot of drilling that goes on in Alberta for discovery of oil. So there's lots of cores. Thousands and thousands and thousands of cores have been drilled down very deep, below the Canadian soils. And those cores then contain a series of layers of the sedimentary and, the geological column. And from those, we can understand the types of environments that are represented by those sediments. And when you put all the columns together, you start to get a picture of the sedimentary profile. And you add to that seismic data. where you're basically peering down through these layers. In fact, they're going to go way down, well over 100, several hundred feet down, and they're looking at a particular layer of rock, the Grand Rapids Formation, from the lower Cretaceous. Again, so over 100 million years old. So let me read what they say about what they did. They have a large-scale well log study that was used to place the seismic stratigraphic architecture in regional context. Seismic facies were calibrated with numerous cores and wells. The data reveal that the Grand Rapids Formation was composed of a shore face parasequences cut by many incisions filled with fluvial to estuary facies. All right, lots of geological terms here. It'll help when you see the pictures, right, to understand what those terms are. All right, let's just move on down here quickly. Where we're talking about is here in Alberta. And then this is a profile of the Grand Rapids Formation. This formation is a thick layer of rock, which has much rock on top of it. And then there's the Canadian surface up here, okay? And so they're looking and they're asking, like, what does that represent? What does that layer represent over a very large area? Right? A significant area. This is Alberta, Saskatchewan, and down here, United States. And what they're suggesting is that what we have is a bunch of non-marine rock. We have non-marine sedimentary layers. Then we have, as you travel north, you end up with those non-marine layers bleeding into and actually kind of interleaving into eventually what becomes more and more and more and more coastal sands. And then eventually that coastal sand gives way to various mudstones and so forth that would represent when the rivers from the non-marine region, the water flows out and then goes out into the shallow sea that was present at the time. And then that sediment falls out, right? Close to shore, you get all these sands, but farther away from shore, you get sort of the mud and eventually limestone and material out there further. And so that is the overall, was what they're saying. This was the overall topography of the land at the time. It's very different than the land today. This alone doesn't really make sense within a young Earth creationist perspective, because below this, there's thousands of feet of other layers of sediment representing other environmental conditions, right? Topographies. And then stacked on top of it is this layer of rock that represents that particular time period in which these different environments existed, right? Smack dab right in the middle of what presumably was a worldwide flood that covered the entire world and had mixed up all the sediments, and they were falling out into these various layers. How do you fall out into non-marine and marine and coastal sands that are actually between the two? But it gets much, much worse than that, right? More difficult for the young Earth creationist. Here is a mapping, again, of this layer of rock of incised valleys. So in the sediments, right, that are rock today, there are clearly incised valleys into that rock representing ancient streams and rivers that were flowing from the non-marine area through to the coast and then out into the shallow sea. Actually, they wouldn't have. The reason they're incised out there is because the idea is that the sea over millions of years would have gone up and gone down. So there were times when the sea was lower, in which case the river valleys incised down into those sediments, carrying stuff farther out into the lower sea. And then when the water rised again, well, it would have filled up all of those different incisions, right? All those valleys, and then continue to pile stuff up on top. And the same is true even for the land. I mean, there was giant floodplains, and eventually all the incised valleys would get filled again, then more sediment put on top of them, and eventually new river valleys formed that when the land lifted or the sea went down, new valleys were incised below that. So there's like incisions upon incisions upon incisions. I don't know, how do you get incisions into rock, all right, in the middle of a flood, right? How does it become rock and then get eroded as if it looks like there's rivers and streams, and then also get covered up and then become rock itself, which then gets incised in new rivers and streams again? All right, but here we go with the, this is one recreation based on all these different boreholes and so forth and interpretation. But then here's the seismic data, right? And the seismic data is looking at a particular layer of rock and then asking what is the fill, what is the type of rock that's there based on the density of that rock. So what you're going to have is you might have shales and maybe mudstones in flood valleys, but then when it gets incised and then filled, it might get filled with sands, siltstones and so forth, which have a different density, and then the seismic waves bounce off them differently, and you'll see these patterns. And what you see like these meandering stream beds. Let's keep on going. So here is their interpretation of that seismicity. And these would have been riverbeds they're actually, we're going to see in a moment, they're kind of stacked on top of each other. There are different layers. And then so there are some of these riverbeds that existed for long periods of time, but eventually they got covered up. And then there's another river on top of that. Over and over and over again. So presumably for millions of years, this process is occurring. Let's just skip right down to the big figure. I love this figure right here. Cretaceous incised valley fills. And so taking a cross section across a large area of, so you can see here, hundreds of kilometers across, and they have all these bore wells, hundreds of bore wells. They're not all shown here. And with the ground penetrating seismic data that they have, they end up with, you've got these layers and layers and layers of rock. Now this is all, the yellow stuff is more shore face, they're saying, all right, close to shore. And so the idea again is that you have layers of sediment being laid down by water coming from the land, running out into the sea, and then forming these layers of mud and siltstone and so forth, and claystone. And then what happens is, you have situations where maybe the sea level was lower. So this ended up being like land, but then it got eroded out into incised valleys. And then eventually the sea rose again, and then they got filled. But what did they get filled with? They got filled with different sediments than the sediment that was originally there, because this sediment's being brought from somewhere else. And maybe filled fairly rapidly, in which case it's being filled with different material than the surrounding region. And then over here, you've got coastal plain. So these are non-marine rocks. So again, you had marine layers, you had more material brought in. Why do you have non-marine on top of marine? Because you had marine layers, eventually enough sediments being brought from farther away where it's higher elevation, and it's eventually filling in, all right, to the point where it gets to sea level. And then you just have non-marine layers laid down, bays and lagoons, right, which you see are represented near the ocean and the land, right? So all of this is looking very much like a history, right? You have a bunch of history stacked on top of each other, representing different landscapes at different times. So you have the development of surfaces of floodplains. They actually talk a lot about floodplains here. These are large, wide, flat areas that get flooded periodically. And so new sediments brought down there, laying down new layers. And that then fills the valleys that have formed over periods in which there aren't floods, and there's erosion occurring. And then that kind of gets filled in again. And then you get new erosion again that makes new incised valleys. And so all of these things are mapped out, right? They've gone to different areas, and for many, many, many miles have looked in very detail and have shown where these streams and riverbeds were. So look at this. I mean, these are at different levels at the same location, sort of stacked on top of each other. So it's as if like, hey, there was rivers here, and then more material got laid on top, and then maybe millions of years later, we got some new rivers here formed, and then later more material stacked on top. Hey, we've got more rivers here incising various valleys through this. And sometimes they cut all the way down till they cut into the original, a previous incised valley. So it's a very, very complex environment. This shows these flood surfaces here. So primary flood surfaces, layering down lots of material. And then here's these huge incisions, right? Which are, sometimes more than 100 feet deep. So that's where I go back to my picture of the San Juan River, right? That was a giant plain at one time, and it had a meandering river on it. And then the land began to rise, or in this case, maybe the ocean began to fall, in which case those meandering rivers begin to cut down. And as they cut down, they pretty much get themselves trapped into place at that point, especially when they're cutting through rock. And so they get cut down, cut down, cut down, cut down, cut down, until eventually, where the water's going is no longer going down anymore. Or maybe the ocean comes up, or in this case, the ocean rises and then floods the entire incised valley, in which case what happens? Well, it starts to fill with sediments. There's more floods and it fills those valleys, which are now lakes, with sediments. And that's what they're seeing. In the boreholes, they're actually seeing, look, we're boring down into these valleys that are filled with sediments that are very different than the borehole next to it, which has very orderly, like layered sediments. Yeah, lots of seismographs in here from different locations showing their interpretation. Here are some of the boreholes showing all the different sediment profiles. We don't need to go through all these details. The whole point of this is that what you find is in the non-marine layers, you have things like plant debris. You've got what looks to be like, muddy river edges where you have thick material, plant material that is sort of maintaining and holding on to the soils. And so that's what gives you your river valleys. Right. Whereas in the farther north, where you get to the marine sediments, well, then you don't have that plant material. You've got marine fossils there. And so again, you have a continuous layer where it's marine, and then you have coastal, and then you have non-marine. That's consistent with places we have here on Earth today that are gradually laying down floodplains that eventually meet the ocean and then eventually deposit material into the ocean, where there are ocean living organisms that are being, trapped in those sediments. All right, I think that's pretty much all I wanted to show you. There's lots and lots of pictures in here and diagrams and discussions about all the different types of fossils that are found, the different layers that are here, the interpretations of all these different valleys, incised valleys. But I think you get the point, maybe with a figure like this, that this is not an expectation from flood geology, where young Earth creationists are saying, all the geological column comes from extremely rapid deposition of massive columns of water and material being jumbled up and deposited very rapidly. You don't get incised valleys, right? Cut into what is already partially or completely lithified rock, right? This all in their mind would just be soft material. And many of these incisions are not into soft material, as witnessed by the fact, by the angles at which the erosion occurs. If this was just soft mud that was being laid down and somehow you had even under ocean currents cutting that, you wouldn't get the types of incisions that we see here and we actually observe with our eyes. This is observational science here. We're making inferences, yes, about the interpretation from those observations, but these observations are very difficult to find an inference for that fits within young Earth creationist models. All right, let's quit there. That's just a little bit more about this, I think, which is yet another in a long, long, long list of observations we make from the geological column, from the sky above us and the organisms around us that don't fit into a young Earth creationist interpretation of the world. All right, thanks a lot. Talk to you later. Bye-bye.